Hello. So thank you for watching my lecture video. So this is for problems from 31 to 40. Okay. So let's check problem 31. So it says the company has so much money, like 120. So they use this money to pay those people who achieve high performance. Okay. So for achieve high performance, the company will give them some like bonus, right, or award. So we'll give each one like $C. Okay. So the company has 20 employees. So how many uh, how many of them can achieve high performance? So this number not fixed. This number is landing variable. So can be 0, no one, or can be one of them, or two of them, or all of them achieve high performance, right? So this number A follow which distribution? So this is each one has a 2% chance to achieve this. So each one has a 2% to make these things happen. So for each one happening or not happening, right? A high performance or not high performance. So this is a binomial distribution. So we say this is a number of high performance for a binomial distribution. So N is 20. So for each one, P is 2%, 0.002. Okay. Okay. So we know the mean is NP. So NP equal 20 times 0.002 equal 0.4. So we can say that the 0.4 is like, so let's draw the graph like n equals 0, 1, 2, 3, like 4, like this. So the highest is like 0.4. Okay, then so we know then the probability goes down now. N equal 1 here, n equal 2, n equal 3, n equal like this, right? Okay, so we know the probability for n equal 1 is larger than probability for n equal 2, like this, right? Okay. So if n equal 1, this probability, how much is this probability? So n equal 1, we find n equal 1 is thus. 20 chooses 1, and this thing happen. And this 98 happen 19. So we find this probability will be larger than, okay, larger than 0.001. So if n equal 1, so we can set C equal 120, right? But this thing happen, n equal 1, such a chance is larger than 0.001. So the question is, we want to find the maximum for A, C, that this probability for money is not enough, is less than 1%. So if n equal 2, so if n equal 2, n equal 2, we find this is less than 0, 0, 1. So if n equal 2, we can put c equal 60, right? So n equals 3. So n equals 3 is this probability is also less than 0, 0, 1. So in this case, we put c equal 40, right? Okay. So here's maximum of c. So we say maximum of c is 60. In this case, n equal 2. So we can put 60. Okay. Okay, so for problem 32, so we split all people, not all those adults, into 3 parts. Some are low risk driver, so those are count for 50%. Some are moderate, some are high risk, right? So we just split into 3 parts. So here we put this lower risk and moderate risk and high risk. So we can put it as a 50% here, 30% and 20%. Okay, we just split all people into parts. Okay, so let's say because those drivers have no previous driving record, so the insurance company has no idea about them. So we just pick, assume like we just pick them randomly. Okay, so this pick them randomly, and they give the company write 4 new policy for them. Okay, so we want to find what is the probability that those 4 will contain at least 2 more high risk drivers than low. Let's say at least, so here let's say at least 2 more, so high than low, high than low. Okay. Okay, so here we just pick 4. So we just pick 4 people from this population. So pick 4. So it says we just pick 4. So let's say, so we pick more high risk than low risk. So we can pick 4, 0. Okay, and here's 0. So this is one case, right? And then here, let's see, 4, 0, 0. At least 2 more. So if this is 3, at least 2 more. So 3, 0, 1, or 3, 1, 0 is okay. Like we pick 3 high risk, 1 low risk, so the difference is at least 2. So at least 2 more include 2. So this is the question. At least 2 more or include 2 or do not include 2. Okay. 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 So maybe also like can we use this like 202? Like I just pick 2 from here, from high risk, 0 from low risk, and 2 from moderate risk. Okay, so here the question, at least 2 more. At least 2 more. Okay, so at least 2 more means include 2, right? So we have those 4 cases. Then for each case, we can find a probability. So for example, so let's say, so what is this probability? Let's check what is this probability. So from here pick 0, from here pick 1, from here pick 3. So such a probability can be this like okay, so we pick 1. So we pick from here, this probability is we pick 1, pick this from here is 30%. So here percentage, right? So this equal like this thing happen. We pick 1, and we pick 3 from this. So pick 3 from this. Okay, like this, right? So plus, so this 004, so means we from here pick 4 times. Okay, so the probability just like that. Okay, so this is continuous distribution. The continuous distribution, the problem is easy to understand. So such a problem actually is easy thing. So it's a wording problem. So we have density function thus, and x between 0 to 20. So given that this loss, so here x means loss, this loss is exceed 8, what is the probability? So we have this conditions x larger than 8. So under this condition, we want to find this probability larger than 16. Okay, so this probability equal larger than 8. So larger than 16 and larger than 8 is just larger than 16. So we just need to find this probability. Let's say x larger than 8. Okay, so x larger than 8, so equal, so x from 0 to 20, right? So we put a here. So larger than a is this integration from a to 20. So fx dx. So just this, right? Okay, so for this, so by now we want to find the integration. So for this integration, we use substitution. Always, certainly we can separate, right? But here we can use substitution. We regard 20 minus x as t. Okay, 20 minus x. We just set this as t. So this equal. We just take this coefficient outside. So this equal t dt. So, but the negative dt, right? So when x equal 20, t equals 0, and when x equal a, then 20 minus a. So we get this equal this coefficient, then half of 20 minus a squared, right? Okay, so the coefficient. So plug in here, so we don't need to care about it. There's a coefficient 0.0005 and also cancel this half. So we can easily find the answer equal. So this is like 20 minus a square. So here's 20 minus 16 square. Right? Okay, so now it's easy. So problem 34 is quite the same. So this x means lifetime for a machine. Has a continuous distribution over 0.40 and the density function fx is proportional to this. So we need to find the density function is k times 1 plus x squared. So this is density function. And x between 0 to 40. Okay, so maybe we need to find this coefficient k, right? So let's check. Calculate the probability that the lifetime is less than 6. Okay, so we want to find this probability x less than 6. So this is just this integration. So we just put k here. So here, let's see. So from 0 to 6. Okay, 1 plus x squared dx. So just this integration. Okay, and the k is the integration between 0 to 20, not 0 to 40, right? So we just need to find this. In general, we just find this from 0 to a. Okay, so 1 plus x squared dx. We just find this. So for this one, we use substitution. We let this equal 1 plus x as t. So t negative 2 dt. And t from, let's say, 1 to 1 plus a, like this. So t negative 2 is 1 over t, I think. So t negative 2 integrate out, let's say, negative t, t negative 1. So this equal just 1 minus 1 plus a. Okay? So we can plug in here. So this equal, we can say, so this k is when a equal 40, right? So here is 1 minus 1 plus 6, and 1 minus 1 plus 40. Okay? Okay, so let's see. So this is 1 minus 1 over 7, and 1 minus 41. Okay, so let's say 41, so 41 minus okay. So for problem 35, quite the same. Like this, we have a density function, or this is quite the same. So density function is proportional thus. So if x equal k times 10 plus x negative 2. Oh, this problem quite the same. And x from over this problem. I made a mistake. Oh, I made a mistake. This one, this. Okay, so you need changing a little bit. So, yeah. So there's 10 plus x, not 1 plus x. Okay, but the idea is the same. So let's say, so this problem is exactly same as this one. Yeah, less than 6, less than 5. So exactly the same. Okay, so let's say, so let's say we want to find less than 5, so just equal this, equal k, less than, or less than 5, so from 0 to 5, 10 plus x negative 2dx. Okay. So this k, what is k? K is the integration from 0 to 40, right? So again, so we just check, we just find this 0 to a 10 plus x negative 2dx. We just need this integration. So we use substitution. We say 10 plus x equal t. So this one, so equal t negative 2 et, and so t from 10 to 10 plus a. Right? Okay, so for this integration, so we find this equal just 1 over t. Okay, negative, right? So this equal just 1 over 10 minus 1 over 10 plus a. Okay, so maybe we can put it together, the 10 times 10 plus a. So here is a, right? So we can get the formula. Okay, so the questions of p x less than 5, so equal, we say let this a equal 5, so 5, so here over 10 times 10 plus 5, or 15. Okay, then over, so a is 40 over 10 times 50. So cancel this 10, actually we can cancel this 10, right? So this equal 5 over 15. So here is 40 over 50. So this equal 5 over 15. So here, divided by this, multiply this. Okay. Okay. So we can simplify. Okay. So this is 1 over 3 and 5 over 4, right? So this equal 5 over 12. Okay, so here we have this density function. If y equals this, so k is constant, so maybe we need to find this, or we can cancel this. So it depends. Oh, so the question is, what is the conditional probability that v exceed this, given that v exceed this? So our probability actually is like we say v larger than this, and under this condition, and v larger than 40000. So this probability equal v larger than 1000. Okay, so here v larger than 4000. Okay, so what is the density function for V? Oh, so we have this relationship V equal so much of Y. So we just replace to Y. So this one equal P Y large than, so 1,000, okay, a 10,000, so become 0.1, Y larger than 0.1. So here Y larger than 0.4. So since this K cancelled, so we just need to find the integration of Y. Let's see. We want to find this integration Y larger than A, and we forget this this K. So we say this just equal 1 over Y 4 dy, right? So Y from A to 1. So for this one, we use substitution. So let's put it here, so equal, we let 1 minus y equal t. So this equal t4 dt. But this dy equal negative dt. So so the upper bound when y equal 1, this equals 0. When y equal a, so 1 minus a. So we can get integrated out to the 1 over 5, so t5, so 1 minus a5. Okay, so plugging it to answer, so we can 1 over 5 also cancelled. So this equal, we can say answer, so equal 1 minus a 5's power, so this is 0.65 over 0.95, right? Okay, so this equal just like 2 over 3 5's power. Okay. So problem 37, the lifetime for those things is exponentially distributed with mean is 2. So we let this as x. So we say this x actually follow exponential distribution with parameter mean is 2. So this lambda is 1 over 2. Okay. Okay. So the manufacturer agrees to pay full refund. So pay how much? So 200, right? Now pay full refund if the fair fail in the first year. So we put okay. So x the lifetime can be among 1 year or 2 years like that, and 1/2 during second year. So here we pay 200, and here pay 100, and then they will pay 0. So, okay, so this is the payment. So we want to find the expected value for payment. Then just multiply 100. So this is the they need to how much they should be expected to pay in find out how much the company will pay out. Okay, so we just need to find is actually find expected value for payment, right? So this payment, this expected value is equal So from 0 to 1, pay 200. So multiply the probability. Probability is x less than 1. Okay, so plus pay 100. So if there's x between 1 and 2. Okay, so we need to find this. So there's a probability x less than 1 or x between 1 or 2. So we can use integration. But this is exponentially distributed. So we had better to remember the formula. So if a density function is follow this normal distribution, not normal, follow this exponential distribution, then we have this formula: x less than a equal 1 minus e negative lambda a. Okay, and x between a and b, this formula, now this probability equal e negative lambda a minus e negative lambda b. So we just plug in the formula. Okay, so then you don't need to spend a lot of time for calculation, for integration. Okay, so let's apply to here. So equal to 100 multiply this 1 minus e negative lambda is half. So a is 1, right? So that's so plus 100. So multiply this. So e negative half multiply 1, so minus e negative half multiply 2, so negative 1. Okay, so this is expected value for payment for each print. So answer is, so you should multiply 100, right? Okay. Okay, so there's a problem say the insured value x, says x follow a distribution density function thus. Okay, so what we wanted to find is, given that, means the condition problem, given that this is at least 1.5, so we want to find this probability x at least 1.5 under this condition. What is probability that x less than 2? So we want to find this probability, right? Okay, so at the first we say this probability equal px larger than 1.5, and here is x less than 2 larger than 1.5. So by now the question is just to do some integration. So what is x larger than 1.5? So those are integration. So here let's say, so okay, so px larger than 1.5, so equal x from 1.5 to, let's say, to infinity, right? Yeah, x larger than 1. So this equal like 3 saying x negative 4x. So for this one, actually really easy. This equal a negative x negative 3. So part negative. So, okay. So we find this, the answer is x negative 3. So this equal just 1.5 negative 3 power. Okay. Okay, so we know this integration is 1.5 negative 3. And so between 1.2, 1.5 to 2 is just, let's say, so 1.5 negative 3 minus 2 negative 3. Okay. Okay, so then simplify this. Let's say, oh, maybe you can use calculator to find this. Okay. Or maybe we can simplify a little bit. So that's equal 1 minus 2 over 1.5, just like 1.5 over 2 3rd power. Right? Okay. So for this problem, so we, okay, hurricane insurance. So hurricane, so we say in any calendar year, there can be at most one hurricane. So number of hurricane is 0, 1, happen or not happen. We assume at most 1. So no 2, right? So happen or not happen, happen or not happen. So this is just like a binomial distribution, right? Yeah. So happen is 0, 0, 5. So we can regard it as P. So happen is 0, 0, 5. So not happen 0.95, right? So those are independent. Okay. So now let's say we want to calculate the probability that they are fusing 3 hurricanes in 20-year period. So each year, happen or not happen, happen or not happen, right? Happen or not happen. So this number, like number of hurricane in 20 years, this N follows this binomial distribution. So among the 20 years, right? So we just first year 1 0, first year happen not happen, second year happen not happen. So during 20 years period, how many this thing happen? So this binomial distribution. Yeah. So P is 0, 0, 5. Okay. So once we know this, then such a problem become very easy. Just the binomial distribution. We say we want to find what we want to find. They are fusing 3. Fusing 3 is like we want to find n equals 0. Or can be 1, can be 2. Cannot be 3, right? So only the 3 cases. N equals 0. So n equals 0. So we just use the formula. N equals 0 is this thing P happens 0. So not good things 95 happen 20 times. So plus happen 1. Happen 1 is like from 20 choose 1. This thing happen 1. And this thing not happen 19. And so here 20 choose 2 happen 2. So 0, 0, 5, 2. And 9, 5, 18. Okay. So this is the probability. Okay. So here use calculator if you can find it, but the like so those So those are coefficient, this is the binomial coefficient. So you should remember this is just 20 multiplied two numbers. So here also multiply two numbers. So this numerator start from largest number, denominator start from smallest number like 1. So we can calculate this probability. Okay. Okay. So for this probability, it says those loss is have density function like this x. So what is x? X is loss. So the amount of loss follow a distribution with density function thus. Okay. So this loss is from 0 to 1. Okay. So what we wanted to do is we wanted to set a deductible. So deductible suppose C. So once we set a deductible, so this means the payment. So between 0 to C, you pay 0. Between the larger than C, the company will pay. You should pay C. The company will pay X minus C, right? So this is the company pay. So the question is, once we want to set this deductible such that the insurance payment is less than 0.5 is equal thus. So we have thus the payment probability for pay is less than 0.5. Such a probability is thus. Okay. So let's say, so between 0 to C, payment is 0. So this, okay. So this payment will less than 0.5, right? So we say this probability payment less than 0.5 equal, we say equal thus. X, we just say X less than C, right? And plus, so if X here, so payment is X minus C. So payment less than 0.5 is payment is X minus C will be less than 0.5. But this C, X is from C to 1. So payment is X minus C less than 0.5. So this means no. So this means X cannot be 1. This should be larger than at least larger than 0. Pay something, right? So X is less than 0.5 plus C. 0.5 plus C. Okay, right? So when X minus C less than 0.5, payment less than 0.5, right? Okay, so then there's a probability, so density is 2x dx. Okay, so we just need to find that. Okay, so for this part, x between 0 to c is x between 0 to c, so 2x dx. So plus, like this, right? 0.5 plus c, so 2x dx. So 2x, the integration is easy, just x squared. So we know this equal c squared plus this part is this squared minus c squared, right? So we find this equal okay, so now we let this equal this. So we can find c. Okay. So c actually very easy by now, right? We just put this equal take squared point a. Okay, so c equal 0.3. Okay. So this is the lecture for the lecture for problem 31 to 40. Okay, so we can stop here and see you next time. So thank you for watching.